In the early years of the Cold War, deep within the vast and secretive reaches of the Soviet Union, a network of missile sites and engineering bureaus hummed with intense activity. These were places cloaked in absolute secrecy, where the future of Soviet military power was being forged in shadows. The engineers and scientists who staffed these installations worked under a veil of nationalistic fervor and ideological zeal, driven by the conviction that their efforts would guarantee the security and supremacy of the Soviet state in an uncertain world. Behind the thick concrete walls and barbed wire fences, the Soviet Union poured immense resources into developing rocket technology that could rival or even surpass that of the United States. The stakes were monumental. These missiles were not merely weapons, they were symbols of Soviet might, the embodiment of a system determined to prove its superiority on the global stage. Each test, each launch, was a carefully guarded secret, a fragment of a powerful narrative that the USSR sought to control tightly and protect at any cost. The engineers, many of whom had risen from humble beginnings to become the architects of this new era of warfare, took an almost sacred pride in their work. They understood the strategic importance of their rockets, which were designed not only for defense, but as instruments of deterrence and political leverage. Their designs, sleek, imposing, and deadly, represented years of scientific advancement and tireless labor. Yet, despite their confidence in the strength of Soviet technology, there was a persistent awareness of the fragile balance that existed between secrecy and exposure. Security measures around these sites were stringent. Personnel was screened rigorously, movements were monitored, and information was compartmentalized with rigid discipline. Photographs, drawings, and blueprints were classified at the highest levels, with only a select few granted access to the full scope of the missile programs. The goal was clear: to keep Western intelligence blind to the true extent of Soviet capabilities. Any leak could compromise the entire strategic posture of the USSR, potentially inviting preemptive strikes or undermining diplomatic negotiations. This cloak of secrecy extended beyond physical security. The Soviet government crafted an ideological narrative that framed their rocket programs as a testament to socialist ingenuity and resilience, a stark contrast to what they portrayed as the decadence and moral decay of the capitalist West. Propaganda celebrated the achievements of Soviet engineers as victories not only for technology, but for the communist cause itself. To be part of this effort was to be a defender of the motherland and a contributor to the global struggle against imperialism. Yet, behind this veneer of control and confidence, there was an undercurrent of anxiety. The Cold War was not merely a contest of weapons, but a battle for information, and the Soviets were acutely aware that any vulnerability in their defenses could be exploited. The United States, with its vast intelligence apparatus and technological edge, was constantly probing for signs of Soviet advances, seeking to pierce the veil of secrecy that surrounded these missile sites. This invisible game of cat and mouse added an extra layer of tension to the already high-stakes world of Soviet rocketry. In many ways, the Soviet rocket engineers lived in a paradox. They were proud creators of instruments designed to ensure their nation's survival, yet they operated in a climate where distrust and secrecy often isolated them from the outside world, and sometimes even from each other. The pressure to innovate rapidly and maintain absolute confidentiality was immense, and failure was never an option. The success of a launch was celebrated quietly within the confines of the bureaus, while setbacks were often concealed from public view to maintain the image of unyielding strength. The physical landscape of these missile sites reflected this duality of pride and paranoia. Remote locations were chosen deliberately hidden in forests, deserts, or snowy wastelands far from prying eyes and potential sabotage. Camouflage was meticulous, with facilities designed to blend into natural surroundings or disguised with elaborate decoys. Even the workers wore uniforms that marked them as part of a secretive elite, bound by oaths and the weight of responsibility. Within the engineering bureaus, advanced laboratories and workshops buzzed with activity. Scientists pored over complex calculations, tested propulsion systems, and refined guidance technologies. The Soviet Union's ambition was not limited to short-range rockets. They sought intercontinental ballistic missiles capable of delivering nuclear warheads across continents. Achieving this required breakthroughs in materials, science, aerodynamics, and electronics fields, where competition with the West was fierce and relentless. Despite these challenges, the Soviet rocket program made remarkable strides. The launch of the R-7 Semyorka, the world's first intercontinental ballistic missile, was a landmark achievement that underscored the USSR's technological prowess. This missile would later serve as the basis for launching Sputnik, the first artificial satellite, signaling the Soviet Union's entry into the space age. Yet, even as these milestones were reached, the imperative to shield the details of these programs from American intelligence remained paramount. The Soviet leadership understood that their missile sites were more than just military installations. They were strategic assets whose very existence needed to be hidden or obscured to maintain the delicate balance of power. The idea that the United States might discover the locations, capabilities, or readiness of these missile forces was deeply unsettling. Such knowledge could shift the dynamics of deterrence, giving the West a potential advantage in any future confrontation. This environment of secrecy shaped every aspect of Soviet rocket development. It influenced how engineers communicated, how projects were managed, and how information flowed within the military-industrial complex. It fostered a culture of caution and suspicion, where trust was limited and the consequences of breaches were severe. For the engineers, the work was not just a technical challenge, but a high-stakes game of survival in the shadow of global conflict. As the Cold War progressed, the Soviet Union's missile programs became a central pillar of its defense strategy and international posture. The secrecy that surrounded these efforts was both a shield and a burden, protecting vital information while isolating those who held it. In the hidden corridors of missile test sites and design bureaus, the future of modern warfare was being written quietly, meticulously, and behind an impenetrable curtain of secrecy. The intense pride of the Soviet engineers in their secret programs was matched only by their determination to keep their work beyond the reach of Western eyes. It was a race against time and technology, a silent struggle waged in the shadows of the Cold War that would soon face a new and unprecedented challenge from above the emergence of American space-based reconnaissance. In 1959, as the Cold War's shadow stretched ever wider across the globe, the United States embarked on a groundbreaking venture, that would forever alter the landscape of intelligence gathering. The Corona satellite program. It was a bold attempt to peer beyond the veil of secrecy that cloaked the Soviet Union's missile sites and military installations, using the uncharted realm of space to capture images from above. This marked the dawn of a new era, where surveillance would no longer be limited by geography or the constraints of human reconnaissance. The conception of Corona was born out of necessity and urgency. Traditional methods of spying, spies on the ground, intercepted communications, and aerial reconnaissance flights were proving inadequate against the increasing sophistication and secrecy of Soviet defenses. The U-2 spy plane, while revolutionary, flew at altitudes that still left it vulnerable to detection and interception. The United States needed a vantage point that was not only higher but also less predictable, a platform that could circle the globe and gather intelligence without stepping foot on enemy soil. Enter the Corona satellite program, a secret initiative that combined cutting-edge rocketry, photographic technology, and covert operations. The satellites were designed to orbit the Earth, snapping high-resolution images of predetermined targets before ejecting film canisters that would be retrieved mid-air by specially equipped aircraft upon their re-entry into the atmosphere. This method was unprecedented, a feat of engineering and coordination that pushed the boundaries of what was thought possible in space technology. The initial launches were fraught with challenges, technical glitches, failures in film recovery, and the sheer complexity of synchronizing satellite orbits with retrieval planes tested the resolve of the engineers and intelligence officers involved. Each mission was a high-stakes gamble, with the potential to yield invaluable intelligence or end in costly disappointment. Yet, persistence paid off, and early successes began to validate the vision behind Corona. As Corona satellites began to circle the Earth in the early 1960s, they brought back images that were nothing short of revolutionary. For the first time, American analysts could examine detailed photographs of Soviet military installations from space, images that unveiled the scale and scope of the USSR's missile programs in ways previously unimaginable. These photographs included clear views of rocket launch sites, missile silos, and other strategic facilities that had been meticulously concealed from aerial reconnaissance and ground observation. The significance of these revelations was profound. Where once the Soviet Union had operated in relative obscurity, confident that its secretive measures would thwart Western intelligence, the Corona program shattered that illusion. The images exposed the vast network of missile bases scattered across the Soviet landscape, revealing not only their locations, but also the number and types of missiles deployed. This intelligence allowed the United States to better assess Soviet capabilities, adjust its own defense strategies, and engage in more informed diplomatic negotiations. The technological triumph of the Corona program also marked a defining moment in the history of space exploration and military intelligence. It demonstrated the potential of satellite-based reconnaissance as a tool for national security, setting a precedent that would shape decades of intelligence gathering. The ability to observe enemy installations from orbit transformed the calculus of the Cold War, introducing a new layer of transparency and strategic complexity to the rivalry between superpowers. Behind the scenes, the engineers and intelligence officers who operated the Corona program, understood that their work was not merely about technology, but about gaining a strategic advantage in a world where information was power. The images they retrieved were scrutinized with intense focus, each detail analyzed to extract insights about Soviet military readiness, technological progress, and potential vulnerabilities. This intelligence became a critical component of American defense policy and diplomacy. The secrecy surrounding the Corona program was as intense as that which protected Soviet missile sites. Few outside a select circle knew of its existence, and the satellite launches were shrouded in official silence or misdirection. This confidentiality was crucial to prevent the Soviets from developing countermeasures or undermining the program's effectiveness. It also underscored the delicate balance of technological innovation and geopolitical strategy that defined the Cold War era. The early success of Corona encouraged further investment and innovation in satellite reconnaissance. Each new generation of satellites improved on the last, enhancing image resolution, extending orbital duration, and refining recovery techniques. The program's achievements also inspired parallel efforts in other areas of space technology, fueling the broader space race that pitted the United States and the Soviet Union against each other in a contest of technological and ideological supremacy. For the Soviet Union, the emergence of space-based reconnaissance represented a new frontier of vulnerability. The very secrecy and security that had shrouded their missile sites were now being penetrated from above, eroding the strategic advantage they had carefully cultivated. The Corona program's success was more than a technological milestone. It was a psychological blow, signaling that no corner of their military infrastructure was beyond the reach of American eyes. As the Corona satellites continued their orbits, returning ever more detailed images, American policymakers and military planners gained an unprecedented window into Soviet capabilities. This flow of intelligence informed decisions at the highest levels of government, influencing arms control discussions, military deployments, and the broader strategy of containment that defined U.S. policy during the Cold War. The story of Corona was one of determination and ingenuity, a testament to the power of innovation in the service of national security. It was a daring leap into the unknown, harnessing space technology to pierce the darkness of secrecy that had long protected Soviet missile programs. Through these orbiting cameras, the United States gained a new form of vision, one that would redefine the nature of surveillance and alter the course of Cold War history. In the broader context, the launch of the Corona program symbolized a transformation in the very concept of intelligence gathering. No longer limited to human spies or reconnaissance aircraft, intelligence became a domain of satellites and space-based sensors, heralding an era where global observation was continuous, comprehensive, and increasingly sophisticated. This shift not only changed military strategies, but also shaped the geopolitical landscape, as the presence of these silent watchers in orbit served as both deterrent and reassurance in a world teetering on the edge of nuclear confrontation. The early years of the Corona program were marked by a blend of technical challenge, strategic ambition, and the relentless drive to outpace an adversary who had long mastered the art of concealment. These orbiting eyes, circling silently above the Earth, heralded a new chapter in the Cold War, a chapter where the vastness of space became the new battleground for information, and where the secrets of Soviet rocketry, once hidden in the shadows, were brought into the light. As the 1960s unfolded, the Corona satellite program began to deliver on its promise in ways that stunned both military strategists and intelligence analysts. High above the Earth, orbiting silently and invisibly, these satellites returned photographs of the Soviet Union's most closely guarded secrets, images of rocket launch sites, missile installations, and sprawling military complexes that had until then existed only in the realm of speculation and rumor. The clarity and detail of these photographs were unprecedented, revealing a hidden world that Soviet engineers and commanders had labored to keep out of the reach of Western eyes. For the Soviet engineers who had devoted years to constructing these secret missile bases, the realization that their efforts had been exposed was a bitter blow. They had believed themselves masters of concealment, confident that their extensive measures, camouflage netting, decoy installations, and remote locations would thwart any attempt at aerial or photographic reconnaissance. The Corona program shattered this illusion, penetrating the layers of secrecy with a cold, mechanical precision that left no corner unexamined. The photographs returned from space showed the precise layout of launch pads, the presence of missile silos, and the movement of vehicles and personnel. These images were more than just pictures. They were intelligence gold, allowing American analysts to estimate the number, type, and readiness of Soviet missile forces. The Soviet Union's carefully guarded technological progress was laid bare, revealing the scope and scale of their rocket capabilities in stark detail. This exposure caused a profound sense of frustration and fury among Soviet engineers and military officials. The painstaking work they had done in secret years of design, testing, and deployment now seemed vulnerable to the gaze of an unseen adversary. The knowledge that American satellites could observe their missile bases from orbit undermined their confidence in the security of their programs. It was as if the fortress they had built in the shadows was illuminated under an unblinking spotlight. Inside Soviet missile bureaus, discussions grew tense as engineers grappled with the implications of this new vulnerability. The feeling was one of professional affront. Their technical achievements, once shrouded in secrecy, were now being catalogued and scrutinized by their rivals. The exposure was not just a strategic problem, but a psychological one, challenging the engineers' sense of mastery and control over their work. The photographs also revealed something unexpected. The extent of Soviet missile deployment was greater than many in the West had anticipated. This realization sparked a reassessment of American defense priorities and fueled a renewed urgency in the arms race. The images from space confirmed that the Soviet Union possessed an expansive and evolving missile arsenal capable of threatening American cities and military targets across the globe. For the Americans, this intelligence was invaluable. It allowed for a more accurate calibration of strategic deterrence and informed the development of countermeasures and defense systems. The ability to monitor Soviet missile sites continuously from space provided a level of situational awareness that fundamentally altered the dynamics of the Cold War. It shifted the balance from guesswork and speculation to concrete observation and analysis. The Soviet reaction was multifaceted. On one hand, there was denial and attempts to downplay the significance of the satellite photographs, dismissing them as propaganda or exaggeration. On the other hand, there was a grim acceptance that the age of secret missile programs hidden from view was over. The engineers and military planners recognized that they had entered a new era where their actions could be observed and recorded far beyond the reach of traditional espionage. This awareness sparked a flurry of activity aimed at countering the American reconnaissance advantage. Soviet engineers began exploring sophisticated camouflage techniques, creating decoy missile installations, and developing methods to conceal launch preparations. The goal was to confuse and mislead the orbiting cameras, to create an illusion of emptiness where missiles stood ready, or to present false targets that would waste American attention and resources. Yet, despite these efforts, the fundamental reality remained. The Soviet Union's missile sites were no longer hidden from the world's eyes. The advent of space-based reconnaissance had irrevocably changed the nature of military secrecy. The Soviets were forced to adapt to a new paradigm, where transparency, even if unwanted, was an inescapable fact of the modern age. The psychological impact on Soviet engineers was profound. The pride they had once taken in their ability to safeguard their work was tempered by the knowledge that their adversaries could now observe and analyze every detail from afar. This intrusion was not merely a technical challenge, but a blow to their professional identity and the ideological narrative that had framed their work as a triumph of socialist ingenuity and secrecy. At the same time, the photographs from Corona served as a stark reminder of the high stakes involved in the Cold War. The images depicted not just machines and installations, but the capacity for destruction that these missiles represented. For Soviet engineers, this was a sobering acknowledgement of the responsibilities and dangers embedded in their creations. The exposure of Soviet missile bases also had strategic consequences beyond the technical realm. It influenced diplomatic negotiations, arms control discussions, and the broader geopolitical balance. The United States, armed with detailed intelligence, was better positioned to engage in talks from a place of knowledge rather than uncertainty. The photographs lent credibility to American claims and shaped the contours of agreements aimed at limiting the proliferation and deployment of nuclear weapons. Within the Soviet military-industrial complex, the challenge of countering space reconnaissance became a catalyst for innovation. New technologies and tactics were developed to complicate the task of American satellites, including electronic jamming, rapid deployment capabilities, and the construction of underground facilities designed to shield missiles from observation. These adaptations underscored the escalating technological duel between the superpowers, each striving to outmaneuver the other in an endless game of surveillance and counter-surveillance. The Corona program's success also set a precedent that reverberated through the corridors of power on both sides. For the United States, it validated the investment in space-based intelligence and encouraged the expansion of satellite reconnaissance capabilities across multiple domains. For the Soviet Union, it highlighted the vulnerabilities inherent in secrecy and the necessity of evolving strategies to protect national security in an age where space had become the ultimate vantage point. In the halls of Soviet engineering bureaus, the mood was complex, a mixture of frustration, determination, and grudging respect for the technological prowess that had made such reconnaissance possible. The knowledge that their work was now under constant surveillance did not diminish their resolve. Rather, it spurred a renewed commitment to advancing missile technology and developing countermeasures to preserve strategic balance. The photographs from space, once mere images on film, had become powerful agents of change. They transformed the Cold War from a shadowy contest of espionage and guesswork into a high-stakes confrontation played out under the unforgiving glare of orbital cameras. For the Soviet engineers, who had once believed their secrets were safe, this new reality demanded adaptation, innovation, and a recognition that the era of absolute concealment was over. In this unfolding drama of technology and strategy, the Corona program emerged not just as a tool of intelligence, but as a symbol of the shifting tides in the Cold War. It underscored the vulnerability of even the most secretive military programs in the face of relentless surveillance and technological advancement. The engineers who had labored to build the Soviet missile arsenal now faced the humbling truth that their creations could be seen, measured, and understood by their adversaries from a vantage point that no earthly barrier could block. The story of these orbiting cameras, tirelessly circling the globe, was far from over. But for the Soviet engineers and military officials who first confronted the reality of their exposure, it was a defining moment, one that reshaped their understanding of security, secrecy, and the unfolding contest between two superpowers locked in a struggle for dominance that extended beyond Earth's surface into the vast expanse of space. The revelation that American satellites could see through the Soviet Union's once impenetrable veil of secrecy sent ripples through the corridors of power and engineering bureaus alike. Faced with the unyielding gaze of space-based reconnaissance, Soviet military planners and engineers were forced to confront a new reality. Their missile sites, painstakingly concealed for years, were vulnerable to exposure. This realization sparked an urgent and multifaceted response aimed at countering the growing threat of surveillance and preserving the strategic advantage that secrecy had long provided. In the shadowed offices of design bureaus and the command centers of missile bases, a wave of innovation took hold. Soviet engineers, driven by a mixture of frustration and professional challenge, embarked on a campaign to outwit the American eyes in the sky. Their task was daunting: to develop camouflage techniques and deception strategies sophisticated enough to fool satellites orbiting hundreds of miles above the Earth. Every conceivable method was explored, tested, and refined in the hope of regaining the cloak of invisibility that had been so thoroughly pierced. Decoys became a central element of this defensive strategy. Engineers designed fake missile silos and launch pads, carefully constructed replicas that mimicked the appearance and thermal signatures of real installations. These decoys were strategically positioned to confuse American analysts, forcing them to question the authenticity of photographs and complicating their assessments of Soviet missile strength. The goal was to create enough doubt and misinformation to blunt the effectiveness of satellite reconnaissance. In addition to physical decoys, the Soviets intensified efforts to blend their facilities into the natural environment. Camouflage netting was improved with materials that could absorb or scatter radar and optical signals, making detection more difficult. Vegetation planting and terrain alteration were employed to break up recognizable patterns from above. Even the timing of missile movements and maintenance was adjusted to minimize detectable activity during satellite overpasses. This intricate dance of concealment demanded meticulous coordination and constant vigilance. At the same time, Soviet engineers explored technological countermeasures aimed at disrupting or degrading the quality of satellite imagery. Electronic jamming and signal interference devices were developed to confuse the sensors aboard reconnaissance satellites. Though challenging to implement effectively against hardware designed for stealth and resilience, these efforts reflected an escalating technological contest, a race not only to observe, but to deny observation. The psychological impact on the engineers was complex. Frustration mingled with a fierce determination to overcome this new obstacle. The challenge of fooling an adversary who had seemingly conquered the final frontier of surveillance became a professional obsession. For many, it was a test of ingenuity and skill, an opportunity to demonstrate that Soviet science and technology could adapt and prevail even in the face of unprecedented scrutiny. This struggle to counter American space reconnaissance also underscored a broader strategic reality. The Cold War was no longer confined to Earth's surface or atmosphere, but had expanded into space itself. The Soviet leadership recognized that the future of military security depended on controlling or contesting this new domain. Investments in anti-satellite technology, space-based early warning systems, and improved missile mobility reflected this shift in focus, highlighting the increasing complexity of securing strategic assets in a world where observation could come from any angle. Within missile sites, the mood was one of cautious urgency. The exposure of their installations had eroded a vital element of deterrence, the certainty that their capabilities remained hidden from enemy eyes. Efforts to enhance concealment were not merely technical adjustments, but strategic imperatives. The ability to maintain ambiguity about the number and disposition of missiles was crucial to preserving the delicate balance of power and preventing miscalculations that could lead to conflict. This atmosphere also fostered a heightened sense of internal secrecy and compartmentalization within the Soviet military-industrial complex. Information about counter-surveillance measures was tightly controlled, shared only on a need-to-know basis. The very knowledge that American satellites observed their every move added a layer of paranoia and caution, shaping how projects were managed and discussed. Trust became a scarce commodity, and the imperative to protect secrets intensified. Despite these efforts, the fundamental challenge remained. The orbiting cameras of the United States had introduced an unprecedented level of transparency into what had been a shadowy contest. No matter how elaborate the camouflage or sophisticated the decoys, the Soviets were confronting a technological and strategic arms race that demanded constant innovation. Each advancement in concealment was met with corresponding improvements in satellite sensors and analysis techniques from the American side. The exposure of Soviet missile sites also had ripple effects beyond the technical sphere. It influenced how military planners approached the deployment and mobility of strategic forces. The Soviet Union invested in mobile missile launchers and underground facilities designed to reduce vulnerability to observation and attack. These initiatives aimed to complicate American targeting and preserve second strike capability, thereby reinforcing deterrence despite the erosion of secrecy. At the same time, the Soviet response to space reconnaissance highlighted the limits of control in an era defined by rapid technological change. The very tools that had elevated the USSR to superpower status, advanced rocketry, satellite technology, and scientific innovation, also created new vulnerabilities. The challenge was not only to protect existing assets, but to anticipate and adapt to a future where observation and counter-observation would be ceaseless and dynamic. The dynamic between Soviet engineers and American reconnaissance capabilities became a microcosm of the broader Cold War struggle, a contest of wits, technology, and resolve played out in secret laboratories, remote missile fields, and the silent orbits above the planet. Each side pushed the other to new heights of innovation, driven by the knowledge that in this high-stakes game, failure to adapt could have catastrophic consequences. Within this context, Soviet engineers came to view their work not only as a technical endeavor, but as a vital contribution to the survival of their nation and ideology. The pressure to develop effective concealment and countermeasures was immense, but so too was the pride in rising to the challenge. Their efforts embodied the complex interplay of science, strategy, and patriotism that defined the Soviet war machine in the nuclear age. As the decade advanced, the struggle to outmaneuver American reconnaissance technology continued unabated. Satellite imagery improved in resolution and frequency, while Soviet measures to disguise and protect missile sites evolved in response. The interplay of exposure and concealment became a defining feature of the Cold War, shaping military doctrines, intelligence strategies, and technological development on both sides. The Soviet attempts to shield their missile programs from space-based surveillance also reflected a deeper truth about the nature of modern warfare and international competition. In an age where information is both weapon and shield, control over what is seen and unseen can determine the fate of nations. The Cold War's technological arms race extended beyond missiles and warheads to include the capacity to observe, deceive, and survive in a world transformed by the reach of space. This ongoing battle of innovation and counter-innovation underscored the fragility of secrecy in an interconnected and advancing world. For the Soviet Union, the challenge was not merely to build powerful missiles, but to shield them from the penetrating eyes of their adversary, a task that demanded constant vigilance, creativity, and resilience. In the end, the Soviet response to American space reconnaissance was a testament to the relentless drive to adapt in the face of new threats. It revealed a complex dance of technology and strategy, where each side sought to gain the upper hand, not only through force, but through the mastery of visibility and invisibility. The Cold War's silent war in orbit was as much about shadows and deception as it was about missiles and launch codes, a high-stakes game whose consequences would echo far beyond the realms of space and secrecy. The Corona program's impact on the Cold War extended far beyond the technical achievement of orbiting cameras capturing the secret installations. It established a new paradigm for intelligence gathering that reshaped global military strategy and the very nature of international competition. The unprecedented clarity and continuity of satellite reconnaissance introduced a level of transparency that neither superpower could ignore, fundamentally altering how nations perceived and managed the risks of conflict. By setting the precedent for modern satellite intelligence, Corona transformed the way military and political leaders approached national security. No longer reliant solely on human spies, intercepted communications, or risky aerial overflights, policymakers now had access to near real-time imagery from space, providing them with a more accurate and comprehensive understanding of their adversaries' capabilities. This shift enabled more informed decision-making and reduced the uncertainties that had previously fueled suspicion and miscalculation. The long-term strategic consequences were profound. The knowledge that missile sites and military deployments could be monitored continuously acted as a powerful deterrent against surprise attacks and reckless escalations. Both the United States and the Soviet Union recognized that their secret arsenals were no longer hidden away, but subject to constant observation. This awareness fostered a precarious stability where transparency became a tool for managing the delicate balance of nuclear deterrence. For Soviet engineers, the exposure of their secret programs underscored the vulnerability of even the most tightly guarded military endeavors in the age of space surveillance. Their frustration and attempts to conceal installations became part of a larger narrative about the limits of secrecy in a technologically interconnected world. The engineers' experiences highlighted how advancements in reconnaissance technology could outpace efforts at concealment, reshaping the dynamics of strategic competition. The Corona program also catalyzed advancements in satellite technology and intelligence analysis worldwide. Its success encouraged further investments in reconnaissance satellites with improved resolution, broader coverage, and enhanced capabilities, laying the groundwork for the sophisticated space-based intelligence networks that define modern military operations. The integration of satellite data into strategic planning became standard practice, influencing arms control negotiations, military deployments, and diplomatic engagements. At the same time, the program's revelations contributed to a more nuanced understanding of Soviet military power. By providing concrete evidence rather than speculation, Corona helped temper fears of worst-case scenarios while simultaneously confirming the genuine extent of Soviet missile development. This dual effect shaped Cold War policies, balancing deterrence with cautious engagement and arms control efforts. The transformation brought about by space-based reconnaissance extended beyond the military sphere. It influenced international relations by fostering a degree of accountability and transparency previously unattainable. Nations became aware that their actions could be monitored from orbit, introducing a new form of surveillance that held the potential to constrain aggressive behavior and encourage diplomatic resolution. For the Soviet engineers who had once labored in secrecy, their experiences with Corona's exposure left an indelible mark. They came to understand that in the modern world, technological prowess alone was insufficient to guarantee security. The ability to innovate in response to surveillance and to operate within a system of mutual observation was equally vital. Their work thus became part of a broader story about adaptation, resilience, and the evolving nature of global power. The Cold War itself was transformed by the presence of these orbiting cameras, the invisible threads of intelligence that connected capitals and battlefields created a strategic environment where knowledge was as potent as weaponry. The competition between the superpowers was no longer only about the quantity or quality of missiles, but about the mastery of information, how to acquire it, protect it, and use it to one's advantage. This new dimension of transparency, brought forth by the Corona program, introduced a paradoxical element into the Cold War dynamic. While it heightened tensions by revealing capabilities and intentions, it also reduced the likelihood of miscalculation by providing clearer intelligence. The capacity to see and be seen imposed a form of restraint, shaping interactions between the United States and the Soviet Union in ways that influenced diplomatic initiatives and arms control treaties. The engineers and officials who witnessed the unfolding of space-based reconnaissance, came to appreciate that the era of absolute secrecy was over. The Cold War's technological competition had entered a phase where surveillance and counter-surveillance were integral to national security strategies. The orbiting cameras of the United States symbolized this new reality, embodying both a technological triumph and a strategic challenge. In retrospect, the Corona program stands as a milestone in the history of intelligence and international relations. It demonstrated how technological innovation could redefine the boundaries of warfare and diplomacy, turning the vast expanse of space into a domain of observation and influence. The Soviet engineers' frustration at being exposed transformed into a recognition that survival in this new era depended not only on building powerful weapons, but also on navigating the complexities of visibility and vulnerability. The story of Corona and Soviet missile programs encapsulates the profound transformation of the Cold War from a contest of secret arsenals to a nuanced struggle of transparency and strategy. Through the lens of orbiting satellites, the superpowers confronted each other with unprecedented clarity, shaping an era defined by both rivalry and restraint. The simple act of capturing images from space revolutionized military intelligence and international diplomacy, leaving a legacy that continues to influence global security in the present day.